Hey everybody, it's Mrs. Slauson, and sorry I'm out today, but here is learning target number 8, your first attempt. This is the part 3 of 3. If you haven't done any of the parts, I highly recommend that you do this part because this will be the most like what your second and third attempt will be on this, all right? And for my seniors, you will be doing your second attempt on Friday, so I highly encourage you to watch this as well. So all the different ways to solve, whether we're solving an exponential problem or a log problem. And in our first problem, it is an exponent problem. So if I can use my exponent table, that is what I prefer. And I can because there is a row that holds both 3 and the 9. And that row is 3. So the good news is I do not need to adjust the problem on the left side. And then 3 to the second power is making the 9 here, and then a negative 2 is making it 1/9. All right, now that I have a common base, I can ignore those bases, and the exponent becomes this math problem, and I'm just going to start solving. So I'm going to add the 2 over, which gives me 0, and then I'm going to divide by 2, which continues to give me 0. And I do not need to check for extraneous solutions on any problem that starts out exponential. All right, number 2. So number 2, I notice that I have a bunch of logs together on the left side. So the first thing I'm going to do is I will condense that down to 1 log. When you have multiple logs together on a side of the equal sign, just get it down to 1. So if I ignore the log, I want to see this as x squared minus 8 minus that 2, and this minus 2 is about to turn into divided by 2. Let me switch colors on that. So now I can condense it. I'll bring the log back. It has a little 4, and it's x squared minus 8 over 2 equals 1. So all of that x squared minus 8 over 2 is part of the argument. So if you want, you can put it in parentheses. And now what I'd like to do is to start solving for x. But since x is part of that argument, what I'm going to have to do is get to the argument. So I'm going to have to undo the log. And so to undo the log, what I'll do is I'll make an exponent out of both of them. So I'm going to base 4 both sides. And then this base 4 and log base 4 cancel each other out. So I'm left with x squared minus 8 over 2. And on the right side, I have 4 to the first power, which is just 4. And now what I'll do is to solve for x, I need to start moving things away. So first I'll move that divided by 2. So I'm going to multiply by 2. Those cancel each other out. So I'll multiply the other side by 2, which gives me 8. Then I'm going to add the 8 for 16. And then I will square root and get positive 4 and negative 4. Now, since this problem presents as a log, I do need to check for extraneous solutions. So I'm going to take 4 and I'm going to put it in this argument here because the second log does not have any x's for me to substitute into. So if I take the 4 and I square it and then subtract 8, I'll be taking 16 minus 8, which leaves me, or my argument, as a positive number, which is what I want. Now, if I put negative 4 in there instead, well, negative 4 squared is still this 16, and so I'll still have 16 take away, it is 8. So both answers work here, nothing is extraneous. All right, number 3. Number 3 is another exponent problem, so if I can use my exponent table, that would be best. And I notice that there's a row that holds 25 and 625, and that is 5. So 25 is going to be 5 to the second power with a negative 3r exponent. 5 to the fourth power is 625 with its original exponent in parentheses, and 5 to the second power with its original exponent. All right, so now that I'm got my same base, I can just ignore all those bases, but I have to figure out how to connect these exponents. And when you multiply, old-fashioned multiplication symbol looks like an addition symbol. That is how I will connect these exponents. Okay. So I'm just rewriting. And now I'm going to get rid of the parentheses just by distributing. So just doing my math here, distributing. Remember, you can pause the video if I'm going too fast. What I'll do is just clean up this left side, make that negative 10r. And now what I'll do is I'll add 10r to the other side, which gives me positive 8r, divide by 8. And r is worth 1. This problem is not a log problem, so I do not need to check to see if 1 is extraneous or not. I'm good to go. All right, next problem. So my next problem, it's still an exponent problem, but I'd like it to look more like maybe 1. So what I'm going to do is start getting that x lone. So I'm going to subtract the 6. And then I'm going to divide by the 7. And then when I'm ready, I have 12 to the 3r equals 10. And in my exponent table, there's not a row that holds 12 and 10. So that means I'm going to have to log it. I'm going to log base 12 the left side and the right side. And this log base 12 and this base 12 cancel each other out. So I get 3r on the left side. On the right side, this is where I would now push that math button, scroll up, and if you type in, the little 12 and the little 10, I'm doing that right now, so hold on. I get 0. I'm going to round to 3 decimal places like the directions say. And then I'm going to take that number and divide it by 3. And when I'm done, hold on a second, I just lost my calculator. This is my final answer, and I'm rounding to the nearest thousands, 3 numbers behind the decimal. All right, this is not a log problem, so I don't have to check to see if that is exponential. So number 5 is also an exponent problem. I do not see a row that holds both 19 and 60, so I'm just going to have to start to get to m another way. And since all the addition, subtraction's been moved and multiplication, division, to undo that exponent, I will use a log. So I'm going to log 19 both sides. Again, this log base 19 and the exponent with the base of 19 are going to cancel each other out. So I'm just left with 2 minus 3m. On the right side, this is where I would now type in the math, press the math button. Okay, so log, put that little 19 in, put in the 60. And when I do that, I get 1.391. And now I'm just going to work to get n by itself. So I'm going to subtract the 2. And then divide by that -3. And when I'm done, that leaves m at 0.203. All right, number 6, back to a log problem. So I will have to check for extraneous solutions, but the nice thing about this one is this is really similar to problem 1 and the fact that there's a log on each side and they both have a base of 17. So I can just cancel out those logs. And then the arguments are now my math problem. So now I'm going to start to solve for x. I'm going to add this 5x over. So that's 8 with an x equals -10, and now I'm going to subtract the 8 over, and when I'm done, I get -18. So we just want to see if that would be, or turn my argument into a non-positive number. So if I take -18 and put it in this argument, remember, whenever you put a number into your calculator, put it in parentheses. What's going to happen here is that'll be a -4 times a -18. And when you do that, you get positive 72. And when you add 72 with 8, you get a positive 80. If you put it on the right side, and again, I'm going to put that -18 in parentheses. Whoops, lost my 5. Let me switch colors. So the other argument, so I'll take -5 times -18, get a positive 90, subtract 10, and I get 80. And so I do not have an extraneous solution. The -18 works. All right, 2 more. So first thing I notice on both of these problems is I have a lot of logs, so I'm going to condense the left side down. So I don't want 2 logs, I just want 1 log. So 3x squared plus 6 just turns into 3x squared times 6, which becomes 18x squared. Now I can bring the log back. And I think that's probably the most common mistake I do see is we forget to bring the log back after we condense it down. So, all right, now I'm ready to solve for x. There's no addition, subtraction, or multiplication, division to move. Those backwards of the order of operations. So to undo the exponent, I'm ready to log both sides. To undo the log, I'm ready to exponent both sides. So I'm going to make a base of 3. Oh, sorry. take that back. Rewind, rewind, rewind. You're probably like, Mrs. Slauson, sorry, I forgot to bring the log back on the right side. Just like I said, that's a common mistake. All right, so now what I can do is just cross off those logs because they have a common base. Sorry about that. And now to get x alone, what I'm going to do is take the 72 divided by 18. That's going to give me 4. And once I square root 4, I get 2 and negative 2. So again, this is a log problem. Does that make my argument a non-positive number? And this is the only one I have to check. So if I take 3 and I put 2 in parentheses and squared, that's 3 times 4, which is 12. And if I put negative 2 in there, well, that's still a 4, and 4 times 3 is 12. So here both answers work. All right, last problem. So again, I'm going to condense that down. Sorry about that. That's my dog barking. I'm at home. So anyway, let's take the arguments. And this plus here is about to turn into a multiplication. So if you're wondering why am I not changing this addition sign, it's because it's in parentheses. Think of those parentheses as protecting the argument. So now I'll distribute in, or as my students know, the neighbors meet the neighbors. All right, there's my new argument. I brought the log back. And now to solve for x, there is no addition subtraction to move. There's no multiplication division to move on the left side. So to undo the log, I'm going to exponent both sides. I'll make a base of 9. So the base 9 and the log base 9 cancel each other out. Excuse me. On the right side, I have 9 squared, which turns in to 81. Whoops, forgot my x. And now to solve for x, because we have multiple types of x's, I am going to subtract the 81 over. And from there, I'm going to factor. So I need factors of negative 81 that make 24, and those are going to be a positive 27x with a negative 3x. I can do my parentheses, and x is enough to make the x squared, and then x times a positive 27 make this 27x, and x with a negative 3 makes this one. Now I can do the zero product property, what makes each factor 0, and that would be 3. And negative 27. So again, we have a log problem. Let's see if either of those answers makes an extraneous solution. So going back to the original problem, I'm going to write it here, the left side anyway. What I want to know is if I put my arguments, or sorry, my answers in, do they make the does my argument stay positive? So if I put it in here, then yes, I have a log of a positive 27, the log of a positive 3, and so we're good. If I put negative 27 in, so I'm going to do a little erasing. Oops. Then once I add my arguments up, I get negative 3 in one and negative 27, whoops, in the other, and that does not work. My argument has to be positive. So negative 27 is out, and your only answer is 3. And that's it. Don't forget, this is due next class period for Mrs. Slauson anyway, and I will see you guys on Friday.